In this question, you're given a quadratic equation x square minus 2ax plus a square plus a minus 3 is equal to 0. The roots of this equation have to be real and less than 3. If that is so, what is the range of a? That's the question. So now let us write the conditions corresponding to the given conditions. So first condition. So if you draw the graph of this, how should the graph of this look like? Both roots have to be less than 3. If this is my 3, the graph should be such that both these roots should be less than 3. So what are the mathematical conditions which ensure this condition? So first is discriminant is greater than or equal to 0. The second condition is that the x coordinate corresponding to the vertex, has to be less than 3. Minus b by 2a is less than 3. And the third condition is that the graph should rise up before it reaches the value of 3. So the graph has to go up by the time it reaches the value of 3. That means f of 3 has to be greater than 0. So if these three conditions are valid, then the graph will look something like this, right? Now, these two conditions can be applied in the original equation. This condition has to be applied in the transformed equation. But as you can very clearly see, the coefficient of x square, the leading coefficient, is already positive. So the equation need not be changed for application of this. So you can apply all of this in the original equation. So first discriminant is greater than 0. So 4a square b square minus 4 times a square plus a minus 3 is greater than or equal to 0. So this 4 and 4 gets cancelled. A square and a square also gets cancelled. So you have minus of a minus 3 greater than or equal to 0. This implies a minus 3 less than or equal to 0. This implies a is less than or equal to 3. This is the first condition. The second condition is that minus b by 2a will be less than 3. So minus of minus 2a by 2 times the leading coefficient is 2 is less than 3. This implies a is less than 3. That's the second condition. The third condition is that f of 3 is greater than 0. So if you put 3 in the place of x, so 9 minus 6a plus a square plus a minus 3 is greater than 0. This implies a square minus 5a plus 6 is greater than 0. This implies a minus 2 times a minus 3 is greater than 0. So the quadratic expression greater than 0 means a lies outside the roots. It is a is either greater than 3 or less than 2. So let us take all these conditions and see the common solution, because all these three has to happen. So if you take the real line, the first condition says that a is less than or equal to 3. The second condition says that a has to be strictly less than 3. The third condition says that a should not lie between 2 and 3. It is either a is greater than 3 or a is less than 2. Now what is the common interval which satisfies all the three conditions? Obviously you can see that a less than 2 satisfies all the three given conditions. So the final answer is a is less than 2, or a belongs to minus infinity comma open 2. So this is the corresponding interval for a for this condition to be valid. Thank you.